Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on total change. So it turns out if you integrate a rate of change, you get the total change. So it probably doesn't make a lot of sense. Hopefully it will after this example. So let's say the engine of a car traveling on a highway at 100 kilometers an hour uses an amount of fuel given by this function here. A is the number of liters of fuel being used after T hours. So we're looking to find how much fuel is used in the first 3 hours and the next 3 hours. So what does this have to do with change? Well, this is a rate of change. It's like the rate of petrol being used per hour at a given time, at an instantaneous time. This is the rate of change. So if I want to find how much fuel is being used in the first 3 hours, all I need to do is find the total change in the amount of fuel the car had. I mean, that makes sense. You know, if you started with 80 litres and you ended up with 50 litres, then you've used 30 litres. The problem is, though, we don't know how much fuel was in the car to begin with, but we don't need to. And that's because when we're doing definite integrals, we don't need to worry about the constant of integration. So to find the total change in the amount of fuel that the car had in the first 3 hours, I just need to integrate this. This is what we mean by total change. So the answer to A will just be the integral of 10 minus e to the minus t. We're integrating with respect to t. Now, because it's the first 3 hours and t is the number of hours, we're going to integrate from 0 to 3. Here it's t equals 0 to t equals 3. Don't have to put the t equals in. I just thought I'd do it to make things a bit clearer. So let's go ahead and find out what this actually equals. So the integral of 10 will be 10t because we're integrating with respect to t. Now the integral of minus e to the minus t will just be positive e to the minus t because, of course, when you differentiate it, you times by minus 1, you get this. Remember, no constant of integration when we're doing definite integrals. We're just going to evaluate it between t equals 0 and t equals 3. So substituting in t equals 3, we get 10 times 3 is 30 plus e to the minus t. So when t equals 0, this thing equals 0, but e to the 0 is 1. So we need to actually subtract 1. And you get about 29.05. And of course, this was in litres. So that means that the car will have used this much fuel, 29.05 litres, in the first 3 hours. Again, we don't know how many litres were in the tank to begin with. It could have started at 80 and then went down to 50.95 litres. We don't know. All we know is the amount of fuel will have changed by that much. So let's look at part B. Well, part B is very similar. The only difference is it would be the integral from 3 to 6, the next 3 hours. So we don't need to go through and figure out the integral again because we've already done that. The answer to B will be the integral, but instead of being evaluated from 0 to 3, it will be evaluated from 3 to 6. So, substituting in t equals 6, I would get 60 plus e to the minus 6, and then I need to subtract it when I substitute e equals 3. So that would just be minus 30 plus e to the minus 3. So putting that on our calculator, we get about 29.95. So the first 3 hours, it used slightly less petrol than in the next 3 hours. Again, we don't know exactly how many litres were in the tank after 3 hours and after 6 hours. We just know the difference, 29.95 litres. All right, let's look at one more example of total change. So let's look at this example here. The population of fish in a pond increasing at this rate here. The rate's given by this function here, where t is in years. And we're asked by how much will the population increase in 4 years. So this last sentence is asking us for the total change. It's asking us for the total change in population in 4 years. That's what total change means. You know, if the population was 6 and it's gone up to 20, the total change in population is 14. That's what we're being asked about. So the total change is the integral of the rate of change. So we're going to integrate 12 plus 4t to the power of 3 over 2. So of course we're integrating again with respect to t. Now if we want to find the change in population over 4 years, we're starting at 0 years and we're going to 4 years. So all we need to do is evaluate this integral here. So the integral or antiderivative of 12 is 12t. Now to find the antiderivative of this here, so what I do is I increase the power by 1 and I divide by the new power. Remember, no constant of integration because this is a definite integral and I evaluate between 0 and 4. So just making this a little easier to work with, so it's 12t, 4 divided by 5 over 2 gives me 8 over 5. So it'll be 8t to the 5 over 2 over 5, evaluated between 4 and 0. So if I substitute in t equals 4, so I'm just going to get 48 plus, and that will be 51.2. And then if I substitute in t equals 0 into here, I get 0. So just adding 48 and 51 over 2, I get 99.2. It's okay that I didn't get a whole number because, you know, we could be talking about the number of fish in thousands. This could mean like 99,200 fish or whatever. So it's okay that our total change wasn't a whole number. But what I want you to realize is what we found in this line here, it isn't saying that the population started at 0 and then got up to 99.2. I mean, if you have no fish, they can't reproduce and make more of them. It's not saying the population went from 0 to 99.2. It's just saying that this is the rate of change, about 99. So, you know, it could have started at 4 and gone up to 103. We don't know how many fish there were to begin with, but we don't need to know. It just increased by this much. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.